linear equations, which is a review for us in algebra as we move forward with it, but it provides some really good opportunities to combine lots of skills together, like collecting like terms or combining like terms and solving simple equations, substitution for a value of x. It involves solving for multiple variables, and as we progress through algebra, it becomes more and more complicated, and we have to do a really good job keeping track of our evidence. But the basic idea is that we undo what has been done to create the equation, and that involves inverse operations. So keep in mind that you undo division with multiplication and so on. And just keep in mind that division directly relates to multiplication and subtraction directly relates to addition. In our first example that we have here, we've got this equation where we have 6x plus 4x minus 2 equals 15. And immediately in my head, I think that I should simplify the equation as much as possible before I begin to solve it. So I see two terms that have x's in it on the same side of the equation. So I'm going to combine those like terms together, and I'm going to rewrite this equation in a simpler way, and I get 10x minus 2 equals 15. From there, that looks like a simple equation that I would have solved in 7th grade. And when I do this, I want to isolate the variable x all by itself. So the first thing I would do would be to add 2 to both sides, because that forms a zero pair. And we can remember our work with zero pairs. We're always looking to form a zero pair when we can. Negative 2 plus 2 makes 0. We zero out our pairs and we're in really good shape. That leaves us with a pretty simple equation, 10x equals 17. And I chose this equation because I really like the solution. If I divide both sides of the equation by 10, because there were 10 x's and I wanted to know how much is in each group of x, so I divide it 10 ways and I'm left with x equals 17 tenths. Get used to seeing solutions for x that are not integers. We need to get used to doing that because the world works between whole numbers. So we oftentimes, in fact more often than not, will get a solution for x that is not an integer or a whole number. 17 tenths should be substituted back into our original equation, because especially when we get these kind of solutions, we want to make sure that that solution is correct. And I see that there's 6 groups of 17 tenths plus 4 groups of 17 tenths minus 2 should have a value of 15. If I begin to simplify, notice that I chose to keep that fraction there. I didn't simplify it, or I didn't distribute that 6 groups. I left it as 10 groups of 17 tenths. That goes back to the idea of combining like terms. Well, 17 tenths is the same as 17 tenths, so I can combine those together. And then sometimes this is what happens. Well, 10 groups of 17 tenths is going to be easy to simplify into a 17. We have 10 whole groups of 17 tenths, which would make the whole number 17, or the integer 17. When simplified, that gives us 15 equals 15. So think about doing that when you can. We can't always do that, and it doesn't always benefit us to do that, but it's a good idea to look at it when we can do that. Now we've got some distributions. So maybe you need to look at that skill video again from the distributive property, combining like terms with that distributive property, the idea of a generic rectangle. Look at what I did here. I had a dimension of 3 and I had a dimension of 2x plus 2. That's my generic rectangle. Now I could also think of it here as 3 groups of 2x and 3 groups of 2. And you may have seen those arrows before, but we have to distribute that 3 groups of 2x plus 2. So continuing along with that, I see 6x and I see a 6. On this side I see 2x and I see a negative 14. So let me make that disappear, because we want to record that more as what the equation would look like after we started simplifying it and getting rid of those parentheses so we can continue to combine those terms together. We have 6x plus 6 plus 2x minus 14 equals x plus 3. And we see that there's a 6x here and a 6x here. That's a like term that can be combined. That 6 and that negative 14, be careful with that negative symbol. That can be combined as well. So I've got my little system for keeping track of the terms as I simplify them or collect them together, and I'm left with 8x plus a negative 8. Be very careful with that negative symbol. As we continue now, I'm going to just choose to collect the terms, the x terms on the left side. So I subtract an x from both sides of the equation so that I can form that zero pair. Simplified, I would get 7x plus a negative 8 equals 3. And because I chose to isolate the variable on the left side, I'm going to move the constants over to the right side. So I add 8 to both sides of the equation, and I get a value of 7x equals 11, which I have to move down here, and we're continue to simplify by dividing that into 7 equal groups, and we have x equals 11 sevenths. Now I'm going to change screens here because the check is going to take an equal amount of space, but when I do all that work, remember x equaled 11 sevenths, I'm going to substitute carefully back into the original equation. And it's really important that you go back to the original because you may have made a mistake with the distributive property or collecting terms somewhere along the way. So we want to make sure that we simplify very carefully. So I'm down here a couple ways. I decided to leave that 11 sevenths together just like I had on the previous one. And I see my 7 didn't, my denominator of 7 there didn't show up, so I'm going to include that again. And I just start working my way down and simplifying as much as I can. I now have 8 groups of 11 sevenths. I had 6 here and 2 here, so I put those together. Once again, I took that 6 and that negative 14. I combined that as a negative 8. Continuing to simplify, I left the fraction alone and just kept it that group 11 sevenths. And that came down into 7 groups of 11 sevenths. I'm going to let my screen catch up here. My computer's getting slow, but as we put the negative 8 on the other side, or I add 8 to both sides of the equation, I'm left with 11 equals 11. So take a look at those fractions again. They're not so hard to work with. They're not so bad to work with. So we want to make sure that we're still doing our checks even when we have fractions involved. This next example I have is I just put this up here because I want you to know that it's okay to have no solution. Some equations have no solution because their sides aren't the same value. So we check our distribution here and we get 6z minus 21. And then we had 5z's over here and a z over here. I collect those terms together and I get 6z plus 17. Well, if I collect my variable on one side of the equation, you can see that I zero those out. There's no variable left. And we can't have a negative 21 being the same value as 17, so there's no solution. So it is okay to have no solution. And I want you to think about that more as we progress through equations. And then this last example says that we solve for the variable y. Now in this case, we're given the equation. It happens to be in a standard form for linear equations, but it's a 2-variable equation. And we have negative 3x plus 5y equals negative 10. I know I want y to be left by itself, so I'm going to start isolating the variable y. I'm going to add 3x's to both sides of the equation. Notice that negative 10 is not a like term with 3x, so they have to be kept separate of each other. And we're left with 5y equals 3x minus 10. I just decided to reorder because of y equals mx plus b, but we'll see that as we move down here. I had 5 groups of y equal 3x minus 10, so I'm going to divide that into 5 equal groups. And what happens then is I'm left with one group of y, or y equals 3/5 x minus 2. And that should look like y equals mx plus b to you. And it makes sense to have a coefficient, that number in front of the variable. It makes sense to have that show up as a fraction, because if you think back to your work with slope, you'd have rise over run. So all reasons um, to make connections to prior learning. So sometimes we solve for the variable y and we're left with more than one term on the other side. So some basic review in solving linear equations, but it can get kind of complicated as we add in new stuff along the way. Solving linear equations.